Welcome to Study Loop.
Hi, in the given problem, diameter of hollow plastic tube. This is the hollow plastic tube and its diameter is given as 12 centimeter. So its radius will be half of the diameter, means 6 centimeter, or we can say this is 6 into 10 raised power minus 2 meter. Now the wire which is wound over it, this is the wire wound over this plastic tube. This is having a thickness of d, small d, is equal to 0.81 millimeter, or we can say this is 0.81 into 10 raised to the power minus 3 meter. This wire is wound in such a manner that each segment of the wire is in contact with the other segment. So, if we consider whole length of this solenoid to be L, or we can say it to be small l, as the capital L is given as the self-inductance of this solenoid, which is equal to L, capital L is equal to 1.0 Henry. So if we consider this total length of the solenoid to be L, small l, then the number of turns, the total turns in it, N, will be equal to, if we multiply the number of turns per unit length, means here this is D. If we multiply the total turns with the diameter, means D, into N, it will come out to be equal to length of the solenoid, as D is the gap, is the distance occupied by one turn, means the diameter, means the thickness of the wire, and N is the total number of turns. So D into N will be equal to the total length. So we can say N, means total turns, is equal to L by D. Hence, using the expression for self-inductance of a solenoid, which says L is equal to mu naught into N square A by L, where N is the total turns, L length of the solenoid, and A is its area of cross section. So using the value of N, using the expression for L, N as L by D, we can say this is mu naught multiplied by L by D to the whole square into pi R square divided by L. So finally, this expression will be given as mu naught into L square pi R square divided by D square into L. If we cancel this L, it will become mu naught into pi R square divided by D square. So finally, as we have to find the length of the solenoid, here this is L remaining. So expression for the length of the solenoid will come out to be L is equal to L into D square, L for self-inductance, D for the thickness of wire, divided by mu naught into pi, mu naught into pi into R square. So finally, plugging in all known values, this is 1.0 Henry, then this is diameter, means thickness of the wire, which is 0.81 into 10 raised power minus 3 to the whole square, divided by, this is meter, to the whole square, then divided by 4 pi, means 4 into 3.14, this is 4 pi, or after that this is mu naught. For mu naught this is 4 pi into 10 raised to the power minus 7 multiplied by pi again, multiplied by square of radius, which is 6 into 10 raised to the power minus 2 to the whole square. So now it will become 0.81 multiplied by 0.81 multiplied by 10 raised to the power minus 6 divided by 4 pi square multiplied by 36 into 10 raised to the power minus 11 meter, or finally we can say this is 46.2 meter. This is the length of the solenoid and first answer of the given problem. Now we have to find the length of the total wire used to make this solenoid, which may have this much high self-inductance of 1 Henry. So to find it, again we use the total turns, which is given as L by D. So the length of the wire L dash will become circumference of one turn, means 2 pi into R, multiplied by the total number of turns, means this is 2 pi R into L by D. So again plugging in all known values here, L dash means length of the wire used to obtain this solenoid comes out to be, for L, small l, this is 46.2 meter. For D, this is 0.81 into 10 raised to the power minus 3. Then multiplied by 2 pi r, means 2 into 3.14 into 6 into 10 raised to the power minus 2 meter. So this length, total length of the wire comes out to be 2149.2 into 10 meter, or we can say this is 21492 meter, or if we convert it into kilometers, approximately it comes out to be 21.5 kilometer. This much length of the wire will be used to obtain a solenoid having 1 Henry self-inductance, which is almost impossible to obtain. Now we have to find the resistance of whole of the wire used to obtain this solenoid, and that will be given by the expression R is equal to rho L by A, where L dash, length of the wire, A, area of cross section of the wire, we can take it as small a, and rho, resistivity of the copper. We know the resistivity of the copper is 1.68 into 10 raised to the power minus 8 multiplied by L dash, means 21492 meter, divided by area pi r square, where this r is the radius of this wire, means this is 0.81 into 10 raised to the power minus 3 by 2 to the whole square. So finally, if we calculate it, the value of the resistance here comes out to be 701 ohm, or we can say this is 0.7 kilo ohm, and this is third and last answer of the given problem. Thank you.